guys think that the hypotheses were supported based on this and what you read in the paper? Yeah.
So I don't know if I missed this or if they just didn't include it at all, but did they, I know with a lot of the other, like, you know, like the split brain patients and stuff, they will try and find a measure to see if the patients just can't verbally announce their, you know, noticing of a certain object, or if it's an actual, like if they're actually not seeing it at all. Do they do anything, like, I don't know how you would test that, but do they do anything to make sure it wasn't just a verbal?
From what I remember, when they were showing the 2-second scene to get the gist, they specifically picked 2 seconds because they said that if they showed the scene for longer, they feel like that would have contributed to possible verbal deficits or anything like that. I believe that's what they said in the article.
I'm not sure I really understand that. I mean, if the problem is that a person can see something but can't say they see it, I'm not really sure how the length of time they look at it would contribute to that. Can anybody think why that might be?
They might try to have to like explain something a little bit more complicated, whereas if it's just like a 2-second clip, it's like, oh, like a push, you know, someone pushes somebody, or if it's, whereas if it's something else, then, you know, it might be an argument, or just kind of the complexity of what it is that they're trying to explain. But I don't know, with verbal deficits, you would think that there might be some issue if they can't remember what the words are. But most of the time they explain it just in a really awkward way.
Can you go back to the description of the scene, or the whole idea? Was there a picture of any of the scenes in the article?
No.
That's so bad.
They just said they were black and white scenes from everyday life, so just common.
So I'm confused about the bottom part. It's measured the time it took to identify the letters.
That was a separate thing from the scene. So they put 2 letters next to each other that were slightly far apart, and they measured the time it took to
because I was like, what? Where are there letters floating in the air? That's not normal.
Another thing they would do in other, not this one, but in other studies, they would make an F out of little tiny Fs, and they would be able to look at all the little Fs like individually, but they wouldn't be able to see the full big F that was made out of the little Fs. So I thought that was interesting. Yeah.
So it says in the article, if necessary, patients were given unlimited time until it was clear that the patient was unable to report the gist and that any problem was not because of naming difficulties, slow or slurred speech, etc.
Okay, so they basically gave them time so that if they were like, oh, then they would have known that. Okay. So the question is, does the study answer, or does it support or deny the hypotheses? Anybody else have a comment or question about this? So where do they talk about disconnections?
Well, I didn't touch on it as much, but it says in the article, they're talking about, I guess, I don't know how to...
White matter?
Yes, white matter, there we go. So they were comparing the white matter and the gray matter, and they're saying the disconnections from dorsal stream was damaged and in the white matter, and that's what was causing the symptoms of simultagnosia.
Could you go back to the thing that says go back to the pretty pictures, pretty colors. Yeah. So down there it says bilateral damage to the parietal, occipital, and occipital lobes. So not just the cortex, but actually the white matter itself was damaged in those areas. Okay.
Yes.
Okay. So that then does, if it's, well, did they say anything about the cortex, or is it just the white matter? Or do you recall that?
I don't remember.
Anybody else? Yeah.
Didn't they say that they did the DTI to show the connections to this connection?
Mm-hmm. Yeah, that's why you would do the DTI, is to show that. Yeah. But they also did the other MRI, so I assume they were looking at gray matter as well. Maverick?
The ventral stream, they said that it was unilateral lesions that contributed to the ventral stream.
Well, what is it that the dorsal stream contributes to?
It said dorsal simultag, whatever you're gonna call it, has been used to classify poor interpretation of scenes. So that one is more like the objects. To me, it sounds like it's more like the objects, you know, like in the office or whatever. And then it says the ventral simultagnosia, which is unilateral, seemed like it was with the letters where they couldn't see two letters at the same time. I didn't fully understand it. But.
So just thinking not about simultagnosia, but about what you might have learned from the earlier portion of the class, can anybody here remember what the difference is between the functions of the dorsal stream and the ventral stream in the visual system? Somebody's talking, but I can't hear you.
Thinking out loud.
It's the what stream, right? The dorsal? What it is?
Well, you have a 50-50 chance of getting that right. So
Pretty sure so. No?
They sound very expression. So that's the where then?
yeah, the dorsal one is the where, if you want to oversimplify things, and the ventral one is the very good. The ventral one is the what. So if you have damage in the dorsal stream, that suggests, I don't want to say that suggests what, because that kind of sounds like a misleading question. So what does that suggest? Yeah, the spatial relationships among things are not being processed correctly. So when you think about not being able to see more than one thing at a time, in general, what does that mean? So most things aren't like this, although things that are like this would be a special case, right? So that's that square and cross. By the way, I'm just totally making this up as we go along. Okay, so go back to the beginning of that. Okay, so in this case, it's a what? So you look, what is that? It's a square. Okay, now do the same. Okay, now what is it? It's a cross on top of a square. That's what an ordinary person would say, but they're not. So they're even that actually, because you have to know that one thing is on top of another thing. So that's a spatial relationship. So maybe part of the problem they have is that they just cannot grasp the nature of spatial relationships. So that could be part of it. Yeah.
I think the way things are worded also makes a big difference. So, like when you showed us the office,
Go back to the
visual,
office.
and you asked, what do you see? It kind of sounds like a Pictionary thing, so you can take out whatever. And I was wondering if they did that in the methods, how would they have worded it to really get them to understand, I want you to explain the entire image. Does that make sense, kind of?
It does.
I remember that there was another article that I had read where they talked about this, and they compared it with the idea of stereo vision, which is like seeing in 2D versus seeing in 3D, and it's kind of that same thing where they're not able to see the things in reference to each other as far as like distance, and what they had them do was they looked at there was like a square, triangle, and a circle, and they said like, what shapes do you see? And when they were separate, they could identify the shapes, but when they were overlapping, they couldn't identify the shapes. And then the other thing that they did was they had those shapes and they were overlapping, but they started moving them. And then when the pieces were moving, they were able to separate them because that movement let them see, this is separate from this piece, but if they were touching and not moving, then they weren't able to tell.
Well, that's really interesting too, because if everybody with simultagnosia has dorsal stream losses, then you would expect that ability to tell them apart when moving might also be affected in some way.
Yeah.
So, I mean, this is all very overgeneralized, everything we're saying. So, That's a good question about how they do these tests. This is a time where we need to get a neuropsychologist who's actually worked with people with this kind of disorders to tell us how they would do it. I don't know. It's a really interesting question.
Do you think it's possible that maybe like because they're only showing it for 2 seconds, they don't have time to pick out individual things maybe, and that's why they're showing it for 2 seconds. So you say, oh, that's a park.
Mm-hmm. Right. That could be another aspect of it, is that they're going for a particular kind of identification.
You could just ask them whether, like, what do you see in this picture, like what objects versus, like, don't focus on the individual objects, where's the picture as a whole. Because when I first look at that, there's a desk, chair, a shelf. But then if you ask me, like, what is that as a whole, it's like an office.
Well, these were just like they did in the art, when they told us about it, this just in this picture office.
Yeah.
I still think it looks like a furniture show.
Yeah, because I think they said they show them scenes. They show them scenes, so you might say, what is this a scene of?
I really wish we could see some of those scenes. Dang it. I wonder if there were line drawings of things like people standing on a stepladder reaching into a cookie jar. If you remember the thematic apperception test, there are strange little things like that on it. Could you describe some of them for us? You nodded like you know. Do you know any of the others?
There's the fun one is that it's like an operating room, and there's someone laying down, and then there's a little kid with a rifle standing there, and just a bunch of people standing around a guy laying down in an operating room, and it's telling me a story beginning, the middle, and the end.
Oh wow. Wow, they're really fishing for pathology there. Probably getting it too. All right, so go back to the question you had again. So the end. There you go. So, well, those are the hypotheses. That was the first. Okay, so they said the first hypothesis. Well, actually, those hypotheses seem very similar to me, so I have a hard time knowing exactly what they mean, but I assume that the first one is focusing on the idea of bilateral. So why do you think bilateral disconnections might be more problematic than just unilateral disconnections in the same areas? Yes.
Because like you said, the brain uses both sides kind of in general. So if you get both sides hindered, then you're having an issue with communication.
You have no backup, basically. In many cases, one side of our brain can do something maybe a little better than the other, but the other side can still do it. So if you have connection between the sides and one side is working, the other side isn't as vital. This is one of the ideas as to why we even have the two hemispheres the way they are, is so that we have a backup. Kind of like if you're Klingon and you have an extra spinal column. Never mind, okay? So that could be why it's worse, but then on the the ventral simultagnosia, you're saying that was just on one side. So which side was it? Did it matter, or was it any side? I mean, either side, there's only two. Do you guys remember? Can you go back to the pretty pictures? There you go. So, looks like, geez, looks like it varies a lot. So is anybody checking?
In the article, they said the left side was worse.
They did, but I don't know if that means that you would get simultagnosia only if your left ventral was messed up. And you said that that was linked with letters. Why do you think object recognition would be important for distinguishing letters as opposed to other things? Yeah.
Because like a square is like one thing, and like it is a thing, but a letter is like a symbol of a thing. So you kind of have to put together, like there's a line here, there's a line here, there's a line here, and they come together to form an A. But like if you can only see one thing at a time, you can only see one line.
Maybe.
You know, so then you can.
Interesting. So language processing is kind of different from other things. So I don't know that much about language for some reason. Although I like puns, I've never been interested in the neurology or neuropsychology of language. So I know almost nothing about it. Does anybody else here know anything about that might shed light on the question? Yeah.
One thing I think is kind of interesting about language, and it might play into this, but that they say if someone learns 2 languages growing up, that language is stored like in the same part of the brain. Whereas if they learn a second language later in life, that language is stored in a different part of the brain. So I wonder if that sort of letter recognition or word recognition is maybe stored more towards the a basic language area, because it's part of your developing language rather than an object like a what type of object, because we don't start the way we look at letters and the way we look at words put together. We don't have to look at each individual letter.
Right.
We just kind of remember it as like a part of a thing. So I think it is like letters would be more rooted in our language memory, so to speak, more than like an object.
So that, I mean, I think that makes sense. I definitely think I understand what you're saying, which is like, it's like elaborating on what Rachel said, which is a letter is a symbol of a lot more than just, it's not just a picture of lines, it's a thing that has meaning. But I wonder why the ventral damage would be a problem for that, because language is up here, well, over here for most of us. It's not ventral, really. So that's pretty interesting. I mean, obviously there's something going on. It's just wondering what it is. Do they have any speculations about that in the article?
Yeah.
So some research shows that if a person is bilingual, they're better able to see like flicker, so they're better able to see the flickering like of the light. So I'm wondering if that has anything to do with like the ability to see motion, and then relating to what was said before, like if the objects are moving or something is moving, they're better able to see it. So I don't know if there's maybe some kind of connection there.
There must be. I mean, I think everything in there is connected to everything else, which makes it both good and bad. But I still am just kind of puzzled as to what it is about the ventral, which regions of the ventral occipital were messed up, did it say? I mean, I could look at all the stuff again myself, but I'm trying to get other people to participate. So look at the paper and answer the questions if you need to. What was their speculation as to how the ventral damage contributed to this letter simultagnosia? Like we need Jeopardy music or something.
What was the question?
So the question was, what did the article say about potential reasoning, or this would be in the discussion section most likely, how this damage to the ventral area might contribute to this issue? Specifically, that you said it was the letter test that these people had a problem on. That may not be correct, but that's what someone said. I suppose it's possible that they just wrote down their results and didn't have much of a discussion at all.
I think they only briefly talked about it.
What did they say? Can you look?
Ventral simultagnosia has been noted after unilateral damage to the left posterior ventral cortex, mainly involving the temporooccipital regions, characterized by symptoms such as alexia and impaired reporting of multiple letters under brief exposure. So such patients do not have poor interpretation of scenes per se, but their letter by letter reading is accompanied by impairment.
So it's a really different kind of simultagnosia.
Yeah, so it's that letter by letter, they can't put it together to make a word.
So were these people, did they find that there was a relationship between the scene simultagnosia versus the letter simultagnosia, or were those people really split?
Says the
B. B.
It's at the bottom of page 16. Or page 732 on the left side.
So I'm playing this game now where I'm not gonna take over, so somebody else is gonna have to do it, or else we're just gonna sit here until 10:15 in total silence. So those of you who are on deck, you need to speak up, and those of you who aren't on deck, you also need to speak up. Thank you, Andrea.
To me, what I'm reading here, it seems like they are classifying them as two different things. So it says, historically, the term simultagnosia refers to patients with poor ability to interpret complex visual displays, but in fact, it has been often applied in the context of two somewhat different deficits and two different groups of patients.
Aha.
So specifically, the inability to interpret scenes, and then the other one being, sorry, it goes into the next. Involving poor temporal occipital regions is characterized by symptoms such as alexia and impaired reporting of multiple letters under brief exposure conditions. So they do seem to separate the two out. But they're all classified under simultagnosia.
Could the reason that they're all classified under one name be because, like, to a certain extent, stringing letters together is kind of like seeing a scene? Because there's like multiple parts and put together. So could that be why they were thrown in the same category instead of looked at a bit more differently?
That's interesting. Does anyone agree, disagree with that?
I think that if you're looking at anything, you would consider it a scene. If it's more complicated than one stimuli, you consider it a scene because there's so many different parts being put together.
So in the discussion section, they talk about simultagnosia as a disconnection syndrome as a whole because of these disconnections in the attention systems. And so like we were talking about with the ventral and the dorsal streams of connection, how they were damaged. So they're classifying that as a disconnection syndrome. So that could be still separated, like how they were talking about how it was separated between the two different kinds of simultagnosia because of the disconnections. Does anyone have anything to say to that?
neglect have something to do with it? Because I know in the article it mentioned something about double neglect. Double? Yeah, it says, so it says, our data, however, contradicted that the argument that the stimulus, or however you pronounce that, constitutes a form of double neglect, at least in terms of portable damage. I'm just saying that double neglect has something.
What is double neglect exactly? I'm not even sure I know. I mean, I know what I think it is, but I don't know if it is. So now I'm looking that up.
I think in terms of the article, they're talking about extinction and neglect being kind of that double neglect, because if something's extinct, you can't really acknowledge it.
Mm-hmm.
So I think that's what they were referring to, but they were also saying that it was contradicting that. But I don't know how exactly double neglect plays into this.
So that extinction thing, let's look at that again. I don't completely clearly understand that. Can you go back to that page that, so I think it's back a little bit more. There we go. Okay. Contralesional stimulus. So what does that mean? When you say something is contralesional, what does that mean? So if lesions on one side, contralesional stimulus would mean, contra meaning, so why don't you contradict someone? What are you doing? You're speaking against them. Yeah, so contralesional stimulus would be a stimulus that's appearing from or coming from auditorily, or you're being touched on the other side. So here we're talking about vision, so it means it's in the other side of the visual field from where the lesion is. So if you have a lesion in your right parietal lobe, then a stimulus on the left side of your visual field would be contralesional. Okay, so they're saying when there's an ipsilesional stimulus presented at the same time. So if you have damage on your, let's say you have damage on your right side, and you're looking at a visual scene, and let's say there's a bucket on one side and a shovel on the other, the bucket's on the right side and the shovel's on the left side, which one would you see? So I'll say that again, because unless you were listening hard, you might have missed it. So I have damage on my right side. I'm looking straight ahead. I see a bucket on the right side and a shovel on the left side. Which one would I see? The bucket, correct. So I think what they're saying is, if you're, let's say you're getting neurological testing or neuropsych testing, and you're looking at the screen, they show something in your left visual field, let's say the shovel, and you say, oh, that's a shovel. Then they put the thing in your right visual field, and the shovel disappears, and all you see is the bucket. I think that must be what that means. So it kind of, it's like takes over from the other thing. Somebody back there with their hand up.
So I Googled the double neglect thing, and I came up with an article that was talking about double dissociation. Do you think that they could be using that as another like synonym for it?
That would be surprising to me, because double dissociation has a specific meaning in neurology and neuropsychology. That's kind of, it has to do with two deficits and two different kinds of damage, and if you have damage in one place, it messes up one behavior, and if you have a damage in a different place, it messes up the other behavior. It's kind of like a research protocol, double dissociation. So the question about whether double neglect is a part of this, I can't even answer because I'm not sure what it is.
Maybe it's neglect from both visual fields right now.
That seems to be the obvious idea. Yeah, that makes sense. So why do you think, what do you think, let me say, how do I want to say this? Why is this an attention disorder instead of some other kind of disorder? Why isn't this considered to be a, I don't know, an object recognition disorder instead of an attention disorder?
Because they are able to see the object if it's by itself.
Mm-hmm.
Whereas, like, if it was a different kind of disorder, they probably would be able to recognize the object even if it was by itself.
So what do you think, what is attention then? Attention must be more than what we think it is.
Necessary for survival?
Well, that's for sure, yeah.
So I'm remembering back to that video that we watched about people who were having object recognition issues where there was that one guy who talked about how he knew that this was grass because it was green and it grew from the ground and that's what he told grass was told grass was, but he couldn't identify it himself as grass. Whereas I think these people can still identify the objects. It's just not if they have to piece it apart from the whole scene. So the attention allows you to focus in on one thing, and it seems like their attention is kind of forcing them to focus in on one part of it instead of being able to pay attention to the whole part of it.
So then I wonder, I mean, if you think about it from the other side, I wonder if there's an advantage to this of any kind. I wonder if you could imagine, could anybody imagine a potential advantage to having this particular disorder? The kind of job that you might need to have in order to be able to take advantage of this? Yeah.
Maybe if you had to look for flaws, like if you were in quality control, you could look at.
You can only look at one thing at a time.
Yeah.
I wonder if there's, I mean, seriously, now I'm speculating now, but I mean, attention to me is a very strange thing. I find it hard to even contemplate. In fact, I can barely pay attention to the idea. Okay. So, if your attention is, it seems like what's happening here is that people who have this disorder, their attention is sort of forced to be very narrow. Would you say?
Yeah.
It's like they can't spread it out and take in a lot of things at the same time. I could imagine that could definitely be an advantage if that were the only thing wrong with you. I mean, if they have other problems, that could, make it worse. Yeah.
I think it's also kind of similar to that prosopagnosia where they can't recognize the whole face. They see parts of the face. But it's interesting because that's just for the face rather than for a whole scene. And I wonder if they also have issues with that. Probably not. I mean, I guess because we process faces in a different way.
Yeah, there's a place in the brain they call the face area. It is specialized for face processing, but it's unclear whether or not that's really the only thing that it processes, and it's also unclear how much face processing goes on in other areas. But it is definitely, it's in the occipital, inferior occipital lobe, which is kind of near what I was talking about, yeah. The fusiform face area.
But do you think someone with simultagnosia would see it as a face, or because when you're looking, if you would have this disorder, you're looking at a full object, because it was talking about how there's the flashlight and you can widen it or make it smaller. So I'm wondering if you can widen to see the whole face, or if you have to look at.
Yeah, I think that's a really interesting question, and I wonder if anyone has done research on these folks with faces instead of things like crosses and squares and letters or scenes. And do they, if it's scenes from everyday life, do they have people in them, I wonder? I mean, there's this idea now in neuroscience, and I don't know if it's filtered into neuropsychology yet, but definitely neuroscientists are thinking that there are specialized processes in the brain for social stimuli. So I wonder if this particular disorder applies equally to, let's say, if you had one face and then another face right next to it, if they would be able to distinguish those two faces, as opposed to thinking one face or the other face, but not both faces. Yeah.
Well, I'm curious about, like for, I don't know like what kind of disorders, but I know I've heard of like, you know, like tests of giving people different objects, like maybe like, I don't know, just different random like objects, fruit or something that is arranged to look like a face.
Oh, yes.
And since, like, just looking at the readings that are damaged and the people that they looked at, it doesn't seem like the fusiform face area would be damaged. That seems like more ventral, I guess, to the damage that they're looking at. So, like, if that's not damaged, then I wonder if they could then finally put the scene together if it were in the shape of a face rather than something else.
Yeah, me too. Those fruit pictures are really amazing. Fruit and vegetable pictures. Have you guys all seen those? I hope. Yeah, I want one of those actually. So that's another really interesting thing. I'm still stuck on the idea that if I could get this disorder, I might be able to get my work done.
I wonder if they are able to connect ideas to create, for example, if you had on a table like a shovel and a sand bucket and a towel and like a beach umbrella, if you'd be able to say, what is this for? Like a swimsuit, you say, what is this for? Like, oh, it's for going to the beach. If they'd be able to take those those objects and connect them in their head to say, oh, like, what do these things have in common? What would they be used for? Versus just seeing them like in a picture. Because I think that could have other implications as well. So is the problem that they can't see the whole picture, so to speak, or is the problem that they can't connect to the idea between how things are related?
Yeah.
And so, kind of going off of that, I kind of was thinking, I don't remember if it mentioned this, but there's all these issues with their attention systems. So would that lead to more deficits in their memory system? So if they have like different objects for like a beach scene, are they able to store and say, hey, this is a bathing suit, and then look at the next object, this is an umbrella, and be able to put all that together? Or is it also dealing with, say, like their short-term memory, that they're not able to store each individual object and then thus not able to connect each object to another?
From what I've read, because I read a couple of different articles on this, no one really talked about memory in relation to this. So it's possible that, I don't know, I guess it depends on their lesioned areas and maybe if their hippocampus or anything is damaged. But I feel like it might just be more just the attention part of the disorder and the disconnect between the spatial and objects and all of that. But I don't know, I think it's possible that if you presented them with each individual thing, that they might be able to put it together. Yeah.
Well, I'm just like thinking if it was a problem with their working memory, you would see it in so many other applications, and then I think they definitely would have like mentioned that. But also the fact that they only presented it for 2 seconds, I feel like that was another like way of getting around that to make sure it's not a working memory or short memory deficit, because you don't have time to say like, okay, desk, chair, pencil, computer. Like you don't have time to look at all that if you only have 2 seconds. So I feel like that's what they were trying to get at.
Yeah.
Yeah, just go off of memory, like it makes me think, like when we see and when we focus on something, we see that thing and it's our phobia, but then the other things we're not actually seeing them. It's just, you know, how our memory has stored and said this was here, so it must still be here, and you're not actually seeing things until you actually like focus on that. And so I'm wondering, now that you stated about memory, how much memory plays into it, or maybe some kind of disconnect with the, not necessarily damage to the eye, but some kind of disconnect from
the rods and the cones.
Yeah.
So I was going a different route, but when I read it and I was looking at the participants that they had, I thought it was interesting that they grouped people with degenerative diseases with people that had lesions due to strokes and vasculitis, because I feel like they're two different things in that degenerative diseases could affect it in a different way than other lesions would. I don't know if you found anything on that or touched on that at all.
Not specifically, no, because I think they were just more interested in like looking at like what it is, where it's coming from in the brain, so they were just trying to put it all together.
So I've been doing the evil thing of looking at Wikipedia. Okay, and there's a lot of really interesting stuff in here about simultagnosia. It's probably all wrong, but I want to read to you the different, so this just goes to show you, these are the different theories that people have proposed for what the problem is in simultagnosia. So we're talking about it, a minute ago I said it seems like their attention is restricted to a really narrow spotlight. That's only theory number one. There are, the next one is disengagement difficulty. So they can't shift attention. They have normal attention, but they can't shift it to something else. And then here's one called slowed attentional processing. So it just takes them a longer time to do whatever it is that attention normally does. And so they drag kind of behind the speed of reality. Spatial mapping deficits. So this has to do with that dorsal idea that they can pay attention, but they just can't like figure out space. So they don't map things appropriately. Here's another one, deficient pattern analysis. So they have problems understanding shapes, whether they be shapes of people, shapes of objects, shapes of letters. They just can't figure out shapes. And then the last one here is spatial indexing deficits. So the idea here is that when you're first perceiving a scene, you get this, there's a stage of visual processing where you know I don't even know how to speak about this because we can't use words like know because that implies conscious knowledge. But your brain has hold of the idea that there are these different shapes. And then another layer of visual processing puts all the shapes into the right place, and that's called indexing. And so they can't do that properly. Yeah.
That concept itself would be based off of memory, right?
I don't know if it would be memory or not, honestly. Visual processing is mind-bogglingly complicated. I don't know if that stage of it would require memory, but I think what reading this did for me is reminded me again of how shockingly complex our perceptual processing really is. I mean, we look around, we see what's out there, we think, oh, we just take it for granted. This is all the different ideas about what could be going wrong to give people the inability to recognize that that's a cross on top of a square. Think about the level of processing that's going on in all of us right now as we sit here in this room having a conversation about something. We're like a bunch of amazing little computers, way more amazing than our phones. I just think it's mind-boggling. So it also talks about the difference between dorsal and ventral, which is, it seems like if you're going to have simultagnosia, it would be better to have the ventral kind. Because a dorsal simultagnosics have trouble even getting around in a room because they can't see more than one object at a time, so they're constantly bumping into things. Whereas the ventrals can see the different objects, they can't identify them. only one at a time. They can identify them one at a time. So imagine not even being able to register. Like if you walk into this room and you see that table, then you can't see, like, okay, now I see the desk, run into the table, looking at the podium, run into the other table, bumping into people. Imagine trying to walk in a crowded street. Wow, it's really just mind-boggling.
What do you guys think about if someone had dorsal simultagnosia and they bump into the table and they're able to hold on to it while still looking at something else? Do you think that would change their attention or anything like that, and what they're thinking about? Yeah.
I think that would kind of depend on the theory that you're working off of, that like one of the ones that she just talked about, because some of them are like attention, it's like the widening spotlight thing, and then others it's like you have a hard time shifting. I think it would depend on that.
Yeah.
But if it's a sensational type of input, they're touching it rather than having to see it, and that input may be processed different because most of the damage is in the visual area.
Yeah, I was wondering if there was anything about the other senses, or is it strictly a visual deficit?
Yeah.
Has there been any research that looks at the difference between males and females?
Not that I saw specifically, but I don't know. I'm not sure.
I can check on that. I would expect if there were, it would be that it was more common among males, but who knows?
It could also just be a matter of like which sex stroke is more prevalent in, and end up having that specific area damaged.
Because those are like some research does indicate that females have more connections in the hemispheres, whereas males have more connections in the hemispheres. And I wonder if like that would have anything to do with it. And I know that it said that after 13 is when that's happening more, when you see the differences. I wonder what the socialization of the person, how that would affect, like what kind of symptoms they have.
I'm not sure. I read 3 or 4 papers and I didn't see anything about sex differences.
Yeah, because they mentioned the sex of the participants, but they never actually mentioned even in the discussion or the what's called, like for future research, like kind of to focus on.
I'm looking at Google Scholar and I can't find anything at all that even mentions those two things together. So my guess is there's so few people with the disorder that there's like 7 people who have it, so it's hard to do the sex differences test. Okay, so do you guys think the hypotheses were supported? What do you think of the hypotheses? I thought they were crappy hypotheses. That's just my opinion.
Well, this is the first study that has tried to look at multiple people and their exact areas and what exactly is going on.
Okay, that makes me feel better about
Yeah.
the hypotheses. So do you think that they supported their hypotheses based on your reading and the discussion that we've had? So those of you who were on deck, offer an opinion. Maria, you can go first since you've actually spoken recently.
I think so, but there was like you said, I don't know, because there was, like you said, there's a lot of overlapping and like, or not overlapping, like it was kind of everywhere, like the neuroimaging. So it's like, I feel like, I don't know, hopefully future research can find, I don't know, can like narrow it down more.
Maybe to find more people.
Yeah.
What about you?
To be honest, I really don't know.
But
Yeah.
since
That's for sure.
probably, I don't know, maybe the age gap, since if they say that the age gap was from like 20 to like 60, I believe, was it 65? I don't know, maybe that. I can't hear the actual answer.
Was there anybody that had simultagnosia that didn't have a deficit in their white matter in these areas? Do you recall? All right, well, see you guys on Tuesday.